Hi everyone, today we are solving exponential equations with logs. So there are three major steps here. The three steps are isolating, right? So we're going to get the exponential expression by itself. We're going to use a log on both sides, and then we're going to solve as normal. So with our first step being isolate, the first thing that I'm going to do is try to get the exponential equation or expression by itself. Right, so I need to get rid of anything that's on that side. I'm going to go ahead and subtract that 3, and I get 2 to the 3 minus 2x equals 8, like that. So in order to get this exponent out of the exponential location, I'm going to go ahead and use log base 2. Right? Log base 2 is going to allow this exponent, remember with our log rules, the exponent would come out front, and we would have 3 minus 2x times log base 2 of 2. Remember, log base 2 of 2 would be 1. Log base anything of itself would be positive 1. So I would have just this canceling like that. We can basically just cancel this in that way. So I would have 3 minus 2x. However, if I do log base 2 here, I also need to take log base 2 over on the other side of the equation. So this is going to be equal to log base 2 of 8. So 2 to the power of what gives me 8 would be 3. In many situations, this will be something that we don't already know the number. So we're going to have to find the decimal. We'll use our calculator for that. Press functions, go to miscellaneous. You have your log base here. We could say 2 and then put an 8. And here we see that is 3. Right, so our first step was to isolate. We did that step in purple. Our second step was to take the log of both sides. That is in green. And now our third step will be to solve. So I'm going to go ahead and subtract 3 on each side. Again, negative 2x equals 0. Dividing by negative 2, I get x equals 0. And so 0 is our solution here. We can go ahead and check by saying, okay, 3 plus 2 to the power of, go ahead and put parentheses, 3 minus 2 times 0, right, does equal 11. This makes sense to me. 2 minus 0 would be 0, so 2 to the third would be 8. 8 plus 3 being 11. So this does indeed check out, and 0 is my answer. So we have our three major steps here. That first step being isolating. The second step is to use the log on both sides. And the third step being to solve. This is going to be very similar when we have an exponential equation with an e in it, right? In this case, we used the log base 2 because we had a 2 here in our base. Here we're going to use the natural log because we have an e. So first step again is going to be isolate, right? So I need to get e to the x minus 1 by itself. I can go ahead and subtract 1. 3 times e equals 9. I'm going to go ahead and divide by 3. I want to get e all by itself. So e to the x minus 1 equals 3, like this. Right? In order to get rid of e, I want to use the natural log e. Do that on both sides. Natural log. I could put an e there. I don't have to. So this is going to cancel and leave me with just x minus 1. Remember, this is really like moving out in front here. So that would be how we get this here. Equals the natural log of e. Right. From here, my last step is to solve. So I'm going to go ahead and add 1 on each side. X equals, I'm going to leave it here, the natural log of 3 plus 1. Right? This would be my exact answer. Right? My exact answer would be the natural log of 3 plus 1. If I wanted a decimal approximation, I would go to my calculator, I press functions, go to natural log, of 3. Make sure you put outside the parentheses plus 1, and I would get this as my answer, 2.099. This is my approximate answer, right? And these two things are equal to each other. Right? Oh, got a square root of pi going. There we go. Remember, if I want to double check my work, I can always type in each of these pieces as y1 and y2. So I'd have 3e to the power of x minus 1 plus 1 at the end. And I'm going to go ahead and do y equals 10 as my other equation here. I'm going to go to see where they meet, and I can see 2.099. That's how I get my answer here. And that's how I can check my answer here. All right. So when we have one exponential equation, follows these same steps, right? Isolating, taking the log, and then solving. We're going to use the same steps. We're just going to have to do it 2 times for the next one. So for this one, we have 2 exponential functions here. So we can't isolate them, right? So we're going to go ahead and take the log of one of them. So I will do log base 2. I'm going to clear out this side here. I also need to do log base 2 of 5 over here. Right? So log base 2 of 2, remember this would come out in front here. Log base 2 of 2 would cancel and leave me with just x plus 2 equals, on this side, the exponent is going to come out in front. So we'd have x minus 3 times log base 2 of 5. Remember that log base 2 of 5, or log base 2 of a number, is just a decimal. So I'm going to go to my calculator. I'm going to go ahead and go to functions, go to log base, and put in a 2, put a 5 here, and I get 2.3219, etc. Right? This number, right, needs to be multiplied times x minus 3. Right? So I'm really distributing 2.3 into each of these numbers. So I'd have 2.321x, and then I really want to do this number times negative 3. I know it's going to be minus, so I'm going to do times 3, 6.965 really, right? Knowing that there's lots more happening here, is equal to x plus 2. Right, so what I've essentially done is just created a linear equation, but it has decimals in it. So I'm going to go ahead and subtract x on both sides. I get 2 equals 1.3219x minus 6.966. I'm adding that 6.96 on this side. So I'm going to have 8.96. Remember, it's really just this number over here. So I could even just add 2 in my calculator, right, to get what that number is. 66 equals 1.3219x dividing by 1.32. So I'm going to take this number, put in parentheses, that whole thing in parentheses, and now I want to divide it by 1.3219. Get as close as we can. And we would say that we have x equals 6.782. This is an approximate answer. This is not the exact answer, right? If we wanted the exact answer, we would go through this process and we could use the log base 2 instead of the decimal here. Right? One thing you could do if you were super interested, this is like above and beyond. So if you want to be done with the notes, you can, but pretty cool here. You could do this to set up this equation again. I'm going to go ahead and take the natural log of both sides. That's going to kick this out in front. So I'd have x plus 2 times the natural log of 2 equals, this also kicks this out in front here, x minus 3 times the natural log of 5. From there, I'm going to go ahead and distribute in. I'm going to leave it as natural log 2. So natural log 2 times x plus 2 times natural log 2 equals x times natural log 5 minus 3 times natural log 5. Okay. Remember that any number, natural log 2, this is just a number. This is just a number. This is x. This is x. So what I'm going to do is I'm going to go ahead and subtract this to the other side. So I have, and subtract 2 natural log 2 to the other side. So I have, this is canceling. This is canceling. I have x natural log 2 minus x natural log 5 equals negative 3 natural log 5 minus 2 natural log 2. Okay, so this is, I have numbers on one side, x on the other side. I'm going to do a quick trick here, which is to factor out x. So I get natural log 2, x times natural log 2, x times natural log 5, right? Equals, remember this is just a number, so number, put a number there. Now I'm going to divide by natural log 2 minus natural log 5. Right? That's going to leave me with x by itself. You might be wondering, like, what is x by itself anyways? So we have this is our number that's here. We're dividing by that number there. So I'm going to have negative 3 natural log 5 minus 2 natural log 2 over natural log 2 minus natural log 5. So this was my number that was on top. That is right here. And then I'm dividing this on both sides. And that's how this ends up on the bottom here. Here's the magic. If you put negative 3 natural log of 5 minus 2 natural log 2, that's on the top, divided by natural log of 2 minus natural log of 5. You get, oops, x equals 6.782, which as you can see is the exact same number as that. But this is the exact answer. This is the exact answer. Kind of wild, but another way to do it. I would definitely probably recommend working with the decimals unless you are feeling super excited about working with natural logs, but you can do it both ways. Okay, so your steps are isolate, get it by itself if you need to, use a log on both sides, and then solve for x. Solve for x. Ask me any questions that you have. I'll see you all in class.